So, good day everyone, good day class. So today we're gonna tackle about the types of chemical reaction. There are five major types of chemical reaction and these are synthesis, decomposition, combustion, single replacement, and double replacement. These five major types of chemical reaction, we will look at example of each and learn how to tell them apart so that you can look at a chemical reaction and classify it, figure out what type it is. The first reaction that we're going to talk about is the synthesis reaction. Synthesis Synthesis is the creation of a substance by combining chemical elements, group, or simpler molecules or by degrading a complex compound within synthesis. These synthesis reactions are sometimes called combination reaction. Now, synthesis is just a fancy word that means making, and that's exactly what happened in a synthesis reaction. A compound is made from simpler materials. Here's an example of a synthesis reaction. C, which is carbon, comes together with the car- carb- comes together with the oxygen gas, which is O2, and makes carbon dioxide, which is CO2. What we make in this reaction is more complex than two simple things. We start with, here's another example of a synthesis reaction. This example, we take sodium, which is Na, and that makes sodium chloride. We take sodium, sorry. We take sodium, which is Na, chlorine gas, and chlorine gas, and that makes sodium chloride, which is NaCl. What we end up with is more complex than simple things we started with. Now, a quick word about the equation that I'm using in this lesson. Some of this equation that I'm going to be talking about, like this in the example, this one right here, this element, are unbalanced. So there might not be exactly the same number of atoms on both sides of the equation. Now normally it's really important to balance equation, but when we're going to be learning about the different types of reaction, balancing numbers can be a little bit distracting. So here I just want you to focus on elements, um, these elements here and how they are rearranging or combining with each other in different ways. That being said, a synthesis reaction is one where we start with simple materials and put them together to make something complex. If you want to represent a synthesis reaction more generally or more generically, we could say that looks kind of like this. We have A and B combining to make AB. Here, A and B are different elements or they are different compounds coming together to make something more complex. So that is an example of synthesis reaction. So let's move on to the decomposition reaction. A, de- a decomposition or a root is the process by which dead organic substances are broken down into a simpler organic or inorganic matter such as carbon dioxide, water, simple sugars, and mineral salt. Decomposition reaction is the opposite of synthesis reaction. In a synthesis reaction, we put things together, and in a decomposition reaction, a compound is broken down into simpler compounds, or, or all the way down to the elements that make it up. So in this example, here we have water, H2O, and it's breaking down into hydrogen, which is H2, and oxygen gas. These elements that make it up. Now, in a decomposition reaction, you don't have to break things down all the way down to their basic elements. You can also break them down just into simpler compounds. So here is another example of decomposition. For example, CaCO3 which is calcium carbonate, and that gets broken down to two simpler compound, which is Ca2, Ca plus Ca and CaO and CO2. Is not like we're talking this and breaking it down into just calcium and just carbon and just oxygen, but this because these are simple compounds. It is also a decomposition reaction. So if you wanted to come up with a sort of generalized way to write a decomposition reaction, you could write it like this example here. AB breaking apart into A plus B, where AB is kind of compound and A and B are similar compound or elements. So that is an example of decomposition. So next is the combustion. A combustion a compound a combustion is a compound containing carbon and hydrogen and sometimes oxygen combined with oxygen gas to produce a carbon dioxide and water. So combustion reaction is basically a fancy word for burn. And when something burn, what happened is that a compound containing carbon and hydrogen, sometimes oxygen, combines with oxygen gas to produce carbon and water. Here, in our example, CH4, which is a chemical formula for methane, that's a type of natural gas, combines with O2, which is oxygen, and it's formed CO2, which is carbon dioxide, and H2O, which is water. Now, we can start with different things in a combustion reaction. As it says here, the compound usually contain carbon and hydrogen. So here is another example of a combustion reaction. Here, this one starts with C3H8, which is chemical formula for propane, another types of natural gas, and just like with this reaction, we combine C3H8 with oxygen gas, which is O2, and that gives us carbon dioxide and water, this CO2 and H2O. So these two reactions are essentially identical except for the number of carbon and hydrogens in the compound that we start with. It turns out that a lot of things that we burn, like natural gas, diesel gasoline, are really similar, and they only really differ in the number of carbons and hydrogens that are in the molecules that make them up. So combustion reaction for a wide variety of compounds look pretty similar. Now, as this definition says, sometimes we have oxygen in the compound that that has we're burning. Here is one example of a combustion reaction that has oxygen, this TCO2H5OH is a chemical formula for ethanol or ethyl alcohol, and you can see just like this two example, it has lots of carbons and hydrogen, except it also has oxygen as well. That's no big deal because it combusts just like the other two by combining with oxygen and making CO2 and H2O. If we wanted to come up with a general way to write the formula a little bit like this, we start out with something that has carbon and hydrogen in it, and we can have different numbers of carbons and hydrogens. So that's why I put this X and Y here, because a number of carbons, hydrogens varies and it doesn't really matter either. Sometimes the compound has oxygen, which is why I put the oxygen here in the parentheses. We can take this compound. It combines with oxygen and it produces carbon dioxide and water. So this here is a generic general equation for combustion. So combustion reaction. So that is combustion. Example of the combustion reaction. So next is the single replacement. So a single replacement reaction, sometimes called a single displacement reaction, is a reaction in which one element is substituted for another element in a compound. So in a single replacement reaction, what happened is one element start out by itself, replaces another element, and the compound with kicking it out. So here is an example. So this Fe, which is iron, which is these elements that by itself, an iron compound combines with CuCl2, which is copper and chloride. So copper and chloride are paired up, but what happened is iron kicks out copper, which is Cu. So Cu ends up by itself, and Fe, which is iron, takes places of that copper. So now the iron and Cl, they are now paired up. They are now paired up. And now I do like to use an example for a dancing couple in a prom. So imagine you are in a prom, and this guy here, and with this paired couples dancing together happily, and then this red here comes, and and then red comes along, and and like and like he said, in this couple dancing together, like he said, in the blue color, he said, hey, I'm much more cooler, get out there. So that's what happened. So blue got booted out, and and red and green end up together. So that is the example. So in a single replacement reaction, right here, like this Fe, which is iron, is like red. Here, coming up to a dancing couple of Cu and Cl2. It boots out Cu, and Cu ends up by itself. And then red, which is iron, takes place that Cu had, and iron ends up with ends up paired with Cl. So here's another example of single replacement. So here, so Cu in this case is the red character, like we talked about a while ago. So red character, so Cu in this case is the red character, and Cu goes to a dancing couple of Ag silver and nitrate AgNO3. So Cu boots out Ag, so Ag ends by itself, and Cu takes Ag place by pairing up with NO3. So that's how single replacement reaction happens, and a generalized reaction for that would look like this example. A, which is the elements that start out by itself, plus B, C, that's the dancing couple, and then that's give us B by itself, which is these elements that get booted out, and then A and C ending up paired together. So that is a single replacement reaction example. So our last chemical reaction is the double replacement reaction. A double replacement reaction is a type of chemical reaction that occurs when two reactants exchange cation or anions to yield two new products. Double replacement reactions are also called double displacement reaction or metathesis reaction. So in double reaction, single replacement and double replacement are sometimes called single displacement and double displacement. In a double displacement, what happens is that positive and negative ions in two compounds just like switch places, not in the single not in the single replacement, they kicking out an element. So here in the double replacement, they only switches places. Nobody gets kicked out in a double replacement. So in double replacement, here's an example. So it's just like you have two different pairs of dancing couple, and red which to be with the gray and ends up with the green, and blue which used to be with the green ends up with the gray. So nobody getting kicked out, not in the single replacement. So we're just switching dancing partners. So here we have another example of a double replacement in a chemical equation that shows us double replacement reaction. We start out with BaCl2 together and Na2SO4 together, and they just switch places. B B ends up for SO4, there it is, and Na ends up with Cl, there it is right here. There, all these compounds are ionic, which means that we can break them down into the positive and negative ions that they are made of. So here, the positive ions are in are in the blue, are in the blue, and the negative ions are in the green. As you can see, the positive and negative just switch places. So that's it. The double replacement reaction, and if we wanted to come up with a general or genetic way to explain it, we could use this reaction here, the example here down here. So you have AB where A and B are paired up, plus CD where C and D are paired up. And then they switch partners to give us AD and BC. So that is the example of a double replacement reaction. So yeah, that's it. So our five major types of chemical reaction in synthesis, simple things combines together to make something more complex. In decom- in decomposition reaction, something complex breaks apart into simpler pieces. In combustion, a compound that contains carbon, hydrogen, and sometimes oxygen comes together with oxygen gas to make carbon dioxide and water. In single replacement and double replacement are our two dance floor reaction. In single replacement, in single replacement, and elements that's by itself combined with two elements that are paired up, it kicks out one of those elements out so that elements end up on its own, and then that element takes its place. So in double replacement reaction rather, it's like two dancing couples with the partners just just trade places, and B and C and D start out paired together, and A and B ends up together, and A and B and A and and B and C ends up together. So those are the major types of chemical reaction. So I hope you understand my lecture, and in our next lecture we will do some practice problem, so you can look at a bunch of different reaction and figure out what type they are. So that's it for today. So have a nice day. Good luck.